In this tutorial, I'm going to teach you how to calculate the numbers of protons, electrons, and neutrons using the numbers in the periodic table. So this is a Bohr model of an atom. Niels Bohr said that the electrons orbit the nucleus. It's not true. I put a little asterisk next to the word model because I wanted you guys to know that this is not to scale. In real life, electrons are very, very small when you compare it to protons and neutrons. Let's talk about those approximate masses now. Protons we can call P+, and protons have an approximate mass of about 1 atomic mass unit. Electrons we can call E negative, and like I said, they're about 1/2000th the size of a proton or neutron. And so what we can say is that their mass is almost zero. Neutrons are slightly heavier than a proton. Neutrons we can call N0, and neutrons have an approximate mass of around 1 atomic mass unit, even though they're just a little bit more massive. All right, so let's take a look at the periodic table tile that you have in front of you for chlorine. And let's kind of talk about each of those things. First of all, chlorine, right smack dab in the middle, has a atomic symbol of Cl, element symbol of Cl. And then what do those other numbers mean? The first one, the top one, is the atomic number. And the atomic number tells us the total number of protons in the nucleus. And as long as there's not a charge on the atom, as long as the atom is not an ion, this number is also the number of electrons. We'll do charges and ions at a later day, so just know that that rule sometimes is different. The other number on the periodic table is the atomic mass, and on our periodic table that we use in the class, sometimes some of the elements have 2 listed, 35.44 and 35.46 in this case. I always just choose the one on the left if there are 2 listed. The atomic mass tells us the average atomic mass of all the different isotopes of that element. Isotopes are versions of that element. We'll talk about what that means at a later date and how to calculate those too. One number that's not listed on the periodic table is the mass number. The mass number comes from rounding either up or down the atomic mass. And this tells us the number of protons and neutrons in the nucleus, the total number. So for chlorine, it would be 35 protons and neutrons. In fact, let's do a problem. We're going to calculate how many protons, electrons, and neutrons there are in chlorine. What we'll do is we'll write down chlorine's name at the top, and then in parentheses we'll write down Cl. From top to bottom, you're going to write P+, E-, and N0. The number of protons come from the atomic number, 17. Chlorine has 17 protons. Next, you look for a charge. Since there's no charge here, the number of electrons is equal to the number of protons, 17. Neutrons are the tricky one. What we'll do is we'll look at that atomic mass, and we look at the number in the 4th place. I'm sorry, the 10th place. In this case, it's a 4. If that number is 0, 1, 2, 3, or 4, what we'll do is we'll do nothing to the number in that 1's place. So that 35 just stays 35. We don't round it up. The mass number is 35. That tells us that there are 35 protons and neutrons. And since we know that there are 17 protons, what we can do is subtract the 2 to tell us the number of neutrons. Chlorine has 18 neutrons. Let's do another example. How about we do germanium? I want you to write the name of germanium at the top along with its atomic symbol in parentheses, and then from top to bottom write P+, E-, and N0. The number of protons is the atomic number, 32. Next we look for a charge. There isn't one, and so the number of electrons is equal to the number of protons, 32. Next we take the atomic number, 72.63, to figure out the number of neutrons. Let's figure out that mass number. We might have to round up or down. Look at the number in the tenths place. In this case it's a 6. If that number is 5, 6, 7, 8, or 9, then we round up. There are 73 protons and neutrons. And if we know that there are 32 protons, we can subtract the 2 to figure out the number of neutrons. In this case, there are 41 neutrons. What I'd like you to do on your left-hand side of your interactive notebook is tell me the numbers of protons, electrons, and neutrons for the first 20 elements on the periodic table. If you have any questions, raise your hand.